Okay guys, this is section 5.7, and as I said, it's pretty easy. It's about formulas, and there are three formulas that I want you to get. Simple interest is really basic. Interest equals principal times rate times time. We don't even have any problems on that, but you do need to be aware of that formula. And then compound interest. Compound interest is this formula here, A equals P parentheses 1 plus R over N to the NT. The reason we're studying these is because we've got variables up in the exponent. That's exponential equations. And I've written out what each part stands for. A is the accumulated or future amount. That means you're going to put some money in the bank and some stuff's going to happen to it. And how much money are you going to have in the future? 5 years from now, or whatever it is. That's the A part, the accumulated or the future amount. P is the principal or the present value. What money do you put into the bank? R is the interest rate. You'll want to put it in decimal for your problems. N is the number of compounding periods. So if you compound your interest quarterly, N would be 4. Annually, N would be 1. Semi-annually would be 2. Monthly would be 12. Daily would be 365, that sort of thing. T is time, and that's usually in years, and that's the number of years that you leave your money in the bank. The other formula is continuous interest, and it's A equals the principal times the number E raised to the RT, the rate times the time. So we'll see about that one in a minute. Let's look at some examples. Our first example says find the amount that results from each investment. And I've highlighted the numbers that are important. If you take $100, you invest it at 4% and it's compounded quarterly and you leave it there 2 years, how much money are you going to have? It's good to write down the parts. P is 100, R is 0.04, N is 4, that's the quarterly, T is 2. Then it's simply plugging them into the formula. That's not bad. And so we have this, put in the formula and do it with your calculator. Some people are great at putting it all in at once and hitting enter. If not, if you want to make sure you get each part, start here, do 0.04 divided by 4 and hit enter. Add 1, enter. Raise 2, that's the caret key. The 8th, enter. Then multiply by 100. So work your way out. You should get 108.29. It should make sense. If you got an answer that was less than 100, would that make sense? If you invest 100, are you going to end up with less? So it needs to make sense. Your next one, $600 invested at 5% compounded daily after 3 years. P is 600, R is 0.05, N is 365, and T is 3. So here we've just put it in the formula, work it on your calculator, make sure you get 697.09. Make sure that you can do that. How about this one? $40 invested at 7% compounded continuously after 3 years. P is 40, the rate is 0.07, the time is 3. Continuously tells you to use that other formula. And you're going to plug it in. 40e raised to the 0.07 times 3, and you should get 40, is that 47.35, I think? Double check that. Okay? All right. Here's a little bit different kind of question. Find the principal that you need now to get each amount. In other words, you want to have $600 after 2 years. So how much money do you need to put in the bank to get that? You want to have $600. You're going to leave it 2 years. It's going to be compounded quarterly at 6%. So if you write down what your parts are, that's here. The only difference is the 600 is no longer your principal, it's your A. So put that in. And what I would do is find out all of this number. Do 0.06 divided by 4, add 1 to it, raise it to the 8th, and then divide that number into 600. You should get 532.63. In this example, the number you get needs to be less than 600 because you're saying, what do I need to start with to end up with 600? Okay? All right. Now, this last one, which of the two rates would yield a larger amount in 1 year? 9% compounded monthly or 8.8% compounded daily? You're going to use a principal of 10,000. So you just do both of these in the formula and see which one gives you the best rate. And you should get 9%. It should give you this amount. Okay, so you're just trying those and making sure. All right, last example. What rate of interest compounded annually is required to double an investment in 3 years? We don't know how much money. We don't have any of those numbers, but we're saying if I want to start with something P and I want to double it at the end, what's the interest rate that I need? So we're solving for R. Well, what I did was say, okay, I'm just going to call this 2P because I want to double the principal. If I wanted to triple it, I could use 3P. And I've got P there, and everything that I know that that's part of the formula. It's R over N. N's the number of compounding periods. Well, it said annually, so that's 1. And that's 1 times the time, which is 3. Excuse me. So the P's cancel each other out. You're left with 2 equals this. If something's to the cube power and you're looking for R, we need to take the cube root. So here you're taking the cube root of both sides. You get the cube root of 2 equals 1 plus R. Subtract the 1. And now you're ready for the calculator. So you do cube root of 2. And remember that's math. And then there's a little cube root thing. And you can do cube root of 2 minus 1. You get this. Turn it into a percentage. It's 25.992%. Okay? All right, let's look at the problems because they're exactly like the examples that I just gave you. And so I've put the answers here. You should try them and make sure. 600, 12% quarterly, 2 years. See if you can get the numbers that I've got there. Okay. This problem down here. The rest of the problems are just like we did. You can see number 6 is the one where you have to decide. Let's look at the last one. And that one's just like the last example. So I think you can just do them and check and make sure that you've gotten those.